All right, so without further ado, please welcome Ian Soutar. Ideal solar storage batteries invented in 1902 by Edison are rediscovered.
Where was the microphone? Or do you just talk in? They just
Pull it if you
pull
want.
it out. Oh, it comes out.
Yeah, I have my own.
Oh, you brought your own. Okay, is that's working? Okay, I'm better known in Victoria for having worked with Jim Harrington to launch Canada's first hydrogen-assisted sailboat in 2007. And when we did that, we used lead-acid batteries to back up the generation of electricity by hydrogen. And we had a number of failures, and we were really disappointed with the technology. So I started to look at batteries, and go on. Now this car was made, let's go back to the slide again, the original one. So this is Edison with his nickel iron battery, and I have a small version here. This one is made in China, but it's identical except it has modern improvements to it. So, okay, we can go to the next slide. This car was on display at the BC Museum. Did anyone see it at all? It was made in 1910. I believe this one is at the BC Hydro Museum in the interior. So it was made in 1910. It's still running on the original storage battery from 1910. And Jay Leno and his wife, now don't get excited about it in terms of application for cars, because the nickel iron battery is too heavy really for cars. These cars only went 25 kilometers an hour. They had trouble with steep hills, but they kept on running. And Jay Leno and his wife each own one of these and drive it regularly. And both cars have the original storage batteries from 1910, 1911, 1912, something like that. Okay, we can move on. Now, hearing this and doing a lot of research on it, I'll mention briefly that if you go to the wiki and you look at nickel iron batteries and what they say terrible things about them. And this is because the Exide lead-acid battery company in 1970 started to negotiate with the Edison storage battery company to buy their technology. And they bought it in 1972 and took it off the market. So this technology has not been available since 1975 in North America. However, if you look at the wiki article, it says terrible things about the battery. And you think, well, why did all the trains in North America have nickel iron batteries in the caboose from 1920 to 1970 if they were such terrible batteries? And the amazing thing is that most of those trains, when the train fell apart, they moved the batteries to the next train that got built. And then they moved the batteries after a few decades to the next train that was built. So when they were finally abandoned in 1970 for trains, was because there was a rumor that the Exide battery company would discontinue their production. So I bought some from China. This is the Changhong battery company, and they're still making them. And they've actually put 20 years of research into improving them over Edison. Now, to get back to the wiki article, the reason the wiki article says terrible things is that the Exide battery company, when they discontinued them, put out a lot of propaganda on why they were going to discontinue it. And all this propaganda sits on the wiki site. So I'm going to be editing that shortly. So this is my home in Esquimalt, and I have 700 watts of solar panels on the roof. And you go to the next slide. And in my garden shed beside the house, these are nickel iron batteries. There's 22 of them. Each battery puts out 1.2 volts, so this is actually a big circle of batteries that equals 26.4 volts, which is, the DC that I bring to my house for lighting. And these ancient batteries light a little module that's in this box that's an LED, modern LED light. That's equivalent to a 50-watt light bulb, but I was aiming for long-term, like not something that would wear out, but is going to outlast me. So those solar panels on the roof will live longer than me. Those batteries are going to live longer than me. And these lights that I'm building for the house are going to live longer than me. Okay, next. Now, this is the control system used for the nickel iron batteries. They have a peculiar set of characteristics that means that they can't just use them as a lead acid battery substitute, because most chargers are not designed for nickel iron. However, by a very fortunate coincidence, these modern, they're called maximum power point solar controllers, are capable of being, in the software can be adjusted to match any battery chemistry. So I put this in, adjusted it, and it worked great. So there's a picture of, I keep rearranging them. Every time I do it, I arrange them differently. So that's not what they look like now, but it's the same number of batteries. They're connected with, you can't see it too well, large nickel strips to keep minimal resistance between the cells, because each cell is only 1.2 volts, so you need to have a really good connection between them. So, okay. And there's one of the batteries so you can see what they're like. They're pretty basic. They're not filled with acid. They're filled with potassium hydroxide, which is similar to sodium hydroxide, which is oven cleaner. So it's a strong alkali as opposed to lead acid batteries that have sulfuric acid in them. Now, I'll read something at the end about this. They were used in American submarines around the time of the First World War because they solved a critical problem. They don't give off toxic fumes. And in a submarine, that's a critical thing. So in solar homes, if you have lead acid, I never built a solar home until now because I was so disgusted with the idea of having lead acid batteries, masses of them, 500 pounds, 1,000 pounds, 2,000 pounds, which is typical of a solar home. And then you have to discard those batteries every decade and bring in another 500 or 1,000 or 2,000 pounds. And it just didn't seem good for the environment. So I decided to build one with these batteries. Now, this is just, I'm stepping aside here. This is Canada's first hydrogen-assisted sailboat. We did use lead acid batteries in it. I didn't know about nickel irons. Next year we'll be doing the same thing, using nickel iron to buffer the electricity generated by the hydrogen. Now, okay, next. And there's a hydrogen fuel cell such as we used in that boat for generating electricity. Now, one thing about nickel iron is you'll see on the site that they're notorious for giving off hydrogen. It's one of their greatest, put it in quotes, disadvantages. So one research project that I've started up is to see whether or not the case can be redesigned in order to capture the hydrogen separate from the oxygen, to use it because it generates hydrogen as it's being charged, and it may be possible to actually use it and collect that hydrogen. Okay, next. That's the last one, okay.